In this video, we're going to start on making a camera match, and we're going to do that on the same frame as we made our clean plate. So I have exported another version of the clean plate as a PNG format, and we are going to use that then later as an image plane for our camera in Maya. To make our 3D scene and render it eventually, we're going to do that in Maya and render with Arnold. So I have here Maya 2019 in a default setup. And let's make sure that you have the latest version of Arnold installed. So if you go to the Arnold menu and then to About, you can see which version you have right now. So the latest version of Arnold is 5.402. And Maya to Arnold version is 3302. So if you go to the website of Arnold, if you have a lower version number, please go to the Arnold website. And then in the Arnold section under downloads, you can find or you can download the Arnold from Maya plugin for your Maya version. So Maya 2019 in this case. So once you have downloaded it, install it, and then of course restart Maya. Let's now first create a project for Maya. So in the file menu, I will go to project window. So let's create a new project, and then in the location. So in my project folder, I'm going to create a new folder for the 3D scene. And then we can select that as our location for the project. And then the project name will be floating objects. And then underscore Maya as well, so that we know it's in a Maya projects folder. And then we'll see that in our 3D scene, we have our folder floating object Maya. And in here, we have the standard projects folder structure for Maya. So let's then also already save our file, save the scene. Let's also already set up some other things. For example, if you would like to have animation in a further stage of our project, the original footage with the camera is recorded in 25 frames per second. So let's also set that up already. And let's set up, so we're from frame 0, and then let's go to like frame 100 for now. Let's now start on creating our camera match. And for that, of course, we need a camera. So in the create menu, I will go to camera and then hit the options button for the camera. The main concept of making a camera match is that you make a virtual clone of the camera with which you recorded your footage. And so one of the most important things that we need to get right is the perspective of the camera. So this is defined actually by two parameters, the focal length and the aperture. And by default, the film back of a camera in Maya is set to a standard 35 millimeters aperture. So this is the horizontal and vertical film aperture. So these settings are in inch, and it corresponds to a 35 millimeter sensor of a camera. On the other hand, of course, we have our focal length, and the focal length is just the property of the lens of how wide or how tele our image appears. But this is always in conjunction with the film back. And so in this case, because we've recorded our own footage, we know with which camera we recorded the footage. And so we need to set we know the focal length and we know the film back. And so we need to match these two settings to that same camera that we filmed with. So a very good resource for getting the information that you need is this website, vfxcamdb.com. So on this website, you will find a whole list of cameras. And so the camera that we used for this footage is the Blackmagic Pocket 4K. So if we go to there, we can see that here we actually see the sensor dimensions. So sensor dimensions or film back or aperture are all kind of equivalent terms. And so here we see in millimeters 18.96 on 10 millimeters, or in inches 0.746 on 394. What I also know is I used a zoom lens, and the zoom lens was set to approximately 19 millimeters. Now, because it's a zoom lens, it's not very exact. It's somewhere around 19 millimeters, but we can use that as a starting point. So let's set this up already. So we can set the focal length to 90 millimeters. And then the horizontal film aperture in inches is 0.746 and 0.394. So let's create this camera now. So we can now already set our camera a little bit to the side. And so we're going to model a very simple geometry as a reference of our scene. And so if we look at our clean plate, so I'm just going to model an approximate of these two walls, and these we can then use as a reference to further translate and transform our camera until we get a match. So let's create a plane, and in the polyplane input, I'm just going to set the subdivisions to 1, and I'm going to rotate it along the x-axis 90 degrees. So then we can go into vertex mode, just select these, and then I'm just going to hit X and then move these until they snap to this point. And the other ones, these can snap to here. And then we can select the top. And snap them to this point, and these can go already a little bit up. So by default, the scale of Maya is set to centimeters, so let's check that in the preferences and then settings. So you see we have centimeters as our units, and I'm also going to change the grid option. So let's right click on the grid here and then go to grid options. And so we are working with 1 unit is 1 centimeter. So now we have our complete grid is 1000 units. So that's then 10 meters, and the grid lines are 100 units. So 1 meter for every little square that we see on our grid. So let's just move this then to, for example, like 3 meters, or even 4. And then let's move this also a little bit, something like that, to get a kind of similar aspects of that wall. And then let's take that edge and extrude it, Control E as a shortcut, and then extrude it along the Z axis like that. And then you can also just hit Q to go out of that extrude, and then with the move tool, we can just also snap to a certain point here. And let's also make sure that our bottom vertices are on the ground plane. So I'm just going to select them and then just snap them to that. So in one of my viewports, and I want to look through the camera, so we can go to the panels and then take the camera. And then in that viewport, we can go to the view and then import an image plane to this camera. So I want to import an image, and then let's import our PNG clean plate version. So as you can see, we now see that in the viewports. So let's now make sure that we also enable our film gate so that we only see what is visible through the camera. Let's also make sure that on the display render settings, so that our image size is correct. So let's just put it to custom, and so the aspect ratio, or just the pixel resolution, is 4096 by 2160. And so if our resolution is set correctly, we can see that if we switch between the film back and the resolution gate, that they are exactly the same. So that means that when we're rendering out a frame of our scene, it's going to exactly match the gate, or it's going to exactly match onto our filmed footage. As you can see, the resolution is now set to half resolution, but it's just important to have the same aspect ratio. So let's now go to our camera and go to the attribute editor. And so you see that we have our image plane added onto our camera. And here you also see now the camera aperture in millimeters next to in inches. And so sometimes it's a little bit off because this is less precise in inches than it is in millimeters. So we can just adjust that a little bit. So we have 18.96 on 10, and that's the exact aperture gate. Now on our image plane shape, I want this to only be displayed looking through the camera. And let's also go a little bit down. And this depth I also want to adjust so that we can see our simple geometry on top of our image plane. So let's just put this more to like 5,000 or something. So now you can see we see this plane on top of it. So let's now start with our camera and place it a little bit further. And in our camera view, we can set this to wireframe so that we only can see see exactly where these edges are on our image. Now, by default, this wireframe is set to this dark blue. Maybe it's not that clear, so we can change that on our plane objects. We can go to the display and then to the drawing overrides, enable overrides. And then let's set this to index and then just pick a bright color like this bright green, for example. If we now deselect it, you can see that our wireframe is now this bright green, which is more clear to where these lines exactly are. Let's now also get a little bit of more screen estate for our camera. So in the panels, we can say that we want to have two panes stacked so that we have a perspective and the camera view. And we can also make it a little bit larger like that. And so now we can just check this and do the camera transformations in the perspective view. Let's now also make sure that we can see our camera a little bit better in the perspective view, because now it's really tiny. So we can do that in the camera shape and then go to display options, no, object display. And then this locator scale, we can set it to 100, and then we have a big camera in our viewport. So in this stage, we're going to move and rotate the camera to get this, to get the best match possible between the wireframe and our backplate, our image plane. And so for this, we're going to need to switch often between world and object coordinate space. So the default way to switch between the two is if you double click on the move tool, you get this window, and here you have the axis orientation, and here you have object and world. These are the two that we need in this case. And you have the same for the rotate, and we have the same menu here. So to quickly change between those two, for the move tool, you can hit you can hold the W key on the keyboard and then just left mouse button, and then you get this menu where you can switch quickly between world or object space. And for the rotate, we just hold the E key and then left mouse button, and then we get the same two things. So I'm now just going to fast forward a little bit through this process. This is already fitting much better, but we want to see better where this line exactly is matching on the lines here in the back. So if we go back to our attribute editor and then to the image plane. So now we are importing this image with an sRGB color space. So that means the gamma is removed so that the image is in linear space. But then we see on our viewport that we have the same kind of LUT. So the sRGB gamma is again added to it. So this is in the linear, and then in the viewport, like in Fusion, the gamma is added again. But to get a brighter version of this image, we could, of course, just in Photoshop add a brightened image with a gamma and then export that and import that as our image. But the quicker way is to just say to our image plane import that the color space is in scene linear, and let's take sRGB. So that's telling them that it doesn't need to remove the gamma. So that means that our image gets brighter because we have a double gamma encoding added to our image now. And so this way we can actually see better where exactly this line is hitting the backplate. And so once we have a rather good match, so you see that these lines actually are rather good on hitting these lines on our backplate, we can still adjust a little bit the edges, of course, so that it's better fits here and also here. So once we have this, we can start modeling a little bit more of our scene. And so you see there's still a little bit of an error in our camera match, so we can start transforming the camera maybe a little bit better. And so in this particular case, it doesn't really need to be that exact because we're just using this simple 3D environment then to get reflections on the object that we're then placing in our composite. Now I've just added a few more details like this little patch in the front, but we're going to use our geometry, our scene like this for the remainder of this video. So we can now go to our camera and then in the plane set our color space back to sRGB so that we again get our correct color values. And let's then start on projecting our image onto this simple geometry.